Hello everyone. Now in today's lecture we will go through those chemical reactions of carboxylic acid where OH part of carboxylic acid would be involved. Only OH part would be involved in these reactions, right? If you know, this is how your carboxylic acid looks like. So in these chemical reactions that we would be doing in this lecture, your OH group would be involved, right? And this OH group would be replaced by different groups like Cl group, NH2 group, OR group, or RCOO group, right? So this group, OH hydroxyl part of carboxylic acid, would be replaced by your Cl or your OR, NH2, then your OOCr group, right? And the product that would be obtained by replacing these groups, by replacing this OH group with these groups, right, would be called as derivatives of carboxylic acid, right? So when you replace OH with Cl, what you will get is acid chloride. When you replace OR, this OH with this OR, what you will get is ester, right? And when you replace OH with NH2, what you get is acetamide, right? And with this, what you will get is acid anhydride, right? So all these compounds that are obtained by replacing OH part of carboxylic acid with these groups are known as, these are your derivatives of carboxylic acids, right, which are obtained by replacing OH group with these different groups, right? And why we call as derivatives? Derivatives are generally compounds that are made from the parent compound. So here the parent compound is carboxylic acid, right? And these acid chlorides, esters, acetamide, acid anhydride are derived or made from carboxylic acids, right? So these are derivatives of carboxylic acids. Now let's look into now chemical reactions. Let's first look at reactions where this OH group would be replaced by Cl group, right? So let's take an example of acid CH3COOH, right? If you treat acetic acid with PCl5, phosphorus pentachloride, it will form, here just notice that your OH group, this group would be replaced by Cl group that will come from PCl5, CH3CO. Now this OH would be replaced by Cl, right? And the other products would be POCl3 plus HCl, right? So what you obtained is acid chloride, which is a derivative of carboxylic acid, right? The other is you treat with phosphorus trichloride. We know you have two chlorides of phosphorus pentachloride and phosphorus trichloride. So with trichloride also the same thing happens. This OH would be replaced by Cl to form CH3COCl plus H3PO3. This is your acid chloride. The third important reaction is you treat acetic acid with thionyl chloride. This compound is SOCl2 is thionyl chloride. Let me just write it here. Right? When you react it with thionyl chloride, it will form CH3COCl plus sulfur dioxide plus HCl. This reaction is important, right? And this is the best reaction for the preparation of acid chlorides. The reason being, the byproducts sulfur dioxide and HCl will leave the reaction mixture, and what you will get is pure acid chloride, right? That is why this reaction, preparation of acid chloride from thionyl chloride, is beneficial, because the byproducts will leave the reaction mixture, because these two byproducts are gases, right? So they will leave the reaction mixture. These are gases. They will leave the reaction mixture, leaving behind pure acetyl chloride, right? I hope this is clear. Now let's look at the second reaction, where OH group would be replaced by this OR, alkoxy group, right? What you will get is derivative, which we call as ester, right? So let's look at CH3COOH, right? And how you can replace this OH with OR, alkoxy group, is by treating it with alcohol. Let's write it this way, right? This reaction is a reversible reaction and will take place in presence of sulfuric acid or dry HCl gas. It will take place in the presence of concentrated sulfuric acid or dry HCl gas. When you use dry HCl gas, it is known as Fischer-Spiral reaction. Right? We would be doing this reaction in detail in another video lecture, right? Because it involves a mechanism also, which is mechanism of esterification. So what it forms is OH of this acetic acid would be replaced by this alkoxy group, right? What it will form is this ester, right? Plus H and OH will form water. I hope this is clear, and make sure you understand that this is a reversible reaction, right? So this product is your ethyl acetate. You derived it from acetic acid. This product is your ethyl acetate, right? And this is an ester. Make sure you understand, this is an ester, ethyl acetate, and this reaction is your esterification. This reaction is esterification, right? And what this ester is your derivative of carboxylic acid, which is made by replacing OH group with alkoxy group, OC2H5. You can see here OC2H5 is added, right, to form this ester, which is ethyl acetate, right? Formation of ester, the reaction where ester is formed is known as esterification, right? In another video lecture, we will take up the mechanism of this reaction, right? So two reactions are done. Now let's look at acetamide, formation of acetamide. And acetamide, that is replacing OH with amino, NH2 group, is done by reacting your acetic acid with ammonia, right? So if you react with ammonia, it will form first ammonium acetate, right? And this ammonium acetate on heating will form CH3CO NH2, right? Here water would be eliminated. This is your acetamide, right? I hope till this point it is clear. So these are amides, right, which are resulted by reacting with ammonia. You take ammonia, it will form ammonium acetate. Ammonium acetate on slight heating will lose a water molecule and it will form amide. The name is acetamide. The other is acid anhydride. Now anhydrides, we know anhydrides are those compounds that are formed by losing a water molecule, right? When a water molecule is lost, right, in a reaction, what forms is an anhydride, right? So here similar reaction will take place where two molecules of acetic acid will react, they will lose a water molecule and they will form acid anhydride, right? And this reaction takes place in presence of phosphorus pentoxide, because since in this reaction what we are doing is we are removing a water molecule. So in order to remove a water molecule, what we need is a dehydrating agent. Dehydrating agent, what it does is it will remove water molecule, right? So here you have let's say CH3COOH, 2 molecules of acetic acid we will take, right, and in the presence of a dehydrating agent, phosphorus pentoxide, it will leave a water molecule like this. Water molecule would be eliminated, minus H2O, and you can see that here also this OH would be replaced by OOCR, this, like this, right? This is the reaction. So OH of one molecule of carboxylic acid would be replaced by CH3COO of another molecule of carboxylic acid, and what it will result into is an acid anhydride. Right. This is your acid anhydride. Right. In another lecture, what we will do is we will do this esterification in detail with its mechanism. Right. That is important. That most of the time that has been asked in exams. Esterification reaction along with mechanism. That is why we will take it in another lecture. Right. So what we have done in this lecture is we have looked into those chemical reactions where OH part of carboxylic acid is replaced by different groups, right, to form derivatives of carboxylic acids, right. First is acid chloride, where acid chlorides react with PCl5, PCl3 and thionyl chloride to form acid chloride, right. Then we did esterification, where it formed ester, right, and then we looked into reaction with ammonia, right, where it forms acetamide. Then we looked into the formation of acid anhydride, where a water molecule is eliminated in the presence of a dehydrating agent like phosphorus pentoxide. I hope all this is clear. Thanks.